Okay, hello everyone, and welcome. Y'all, today we're looking at quadratic functions in vertex form. It's similar to what we looked at with absolute value. We have an h and a k, which moves the vertex of the quadratic off the origin. In today's objective, we're going to be doing some graphing. We're going to graph quadratic functions in vertex form. All right, and we'll look at standard form later in the week. Again, the essential question, and you'll need this for the homework check. How do we express a quadratic function that does not go through the origin? Remember, y'all, we've looked at the quadratic parent function, like y equals x squared. It went through the origin. The vertex was at the origin. And then we added the a. And the a changed the shape of the graph. It made it narrower or wider, or it flipped it upside down. But it didn't change the vertex. The vertex stayed at the origin. Well, now we're going to move it off the origin. The a is still there. This is the equation. This is vertex form right down here. Now we just add an h and a k, just like before. And remember, when you're looking for the vertex, you look at the opposite of what this says inside here to find the x coordinate of the vertex, because that says negative h. It's the opposite of the way it reads. But outside here, plus k, that is the y coordinate of the vertex, exactly like it reads on the outside. And the function itself, where the square is, this is kind of the function itself, the quadratic part, just like the absolute value part. Right? The x coordinate reads the opposite from how it appears in the equation. All right, remember we looked at absolute value function. That's kind of what I explained right here. The parent function was y equals the absolute value of x. Then we use the h and the k to move it around from the origin. All right, the h moved the vertex left and right along the x-axis. The h moved it, and the k moved it up and down. Right, it's the same effect with the quadratic function. All right, the same effect with the quadratic function. Ooh, that shouldn't be squared there. I'll have to fix that. All right, guys, you can use Desmos. Again, if you put an equation in there like this, just put it in an equation like this, it'll say, do you want sliders? And just click on the buttons, it'll create sliders. You can slide them around. All right, just remember when this says, when h equals 1, this says x minus 1. That means h is 1. But when k is 1, it'll say plus 1 on the outside. Example 1, guys. What's the vertex of this function right here? And we can plug that right into Desmos and see that the vertex is 2, 5. It's not negative 2, 5. It's 2, 5. It's the opposite of what's inside, exactly what's outside. And that's the most common mistake. When it reads x minus 2, that means the graph is moved 2 units to the right. 2 units to the right and 5 units up. There's the vertex right there, 2, 5. Okay. Next example, if it says plus 2 minus 5. All right, again, we can use Desmos and put it in there. And the opposite of what's inside here, that's negative 2. And exactly what's outside here, that's the y coordinate, minus 5. All right, so it's minus 2 minus 5. It's down here where the vertex is. Again, here I'm talking about the most common mistake. It's the opposite of the way it reads in the equation, is the h, which is the x coordinate of the vertex. And guys, that's where the axis of symmetry is too, right here. X equals negative 2. It always goes through the vertex. So the x coordinate of the vertex, negative 2, that is the axis of symmetry. X equals negative 2. All right, the next one, this just says x squared minus 3. All right, there's nothing inside here with the x squared, so h the x-coordinate of the vertex is 0. H is 0. All right? But negative 3 moves it down 3 from the origin. All right, so the vertex is 0, negative 3. X equals 0 is the axis of symmetry here again, okay? All right, now one that looks like this, where there's nothing on the outside. This time the y-coordinate is 0. All right, minus 1 means plus 1 for the x-coordinate for the h, but the k here is 0. The k equals 0. The vertex, again, it starts at the origin, it slides along the x-axis up to 1. All right, remember, that's a perfect square. So both factors are 1. So it just touches the x-axis in one place. Like the last one, guys, I've been talking a lot about rate of change. Just remember that the value of a changes the shape of the graph because it affects its rate of change. All right, so over any interval, the rate of change of 2x squared is twice the rate of change of x squared over the same interval. Because again, that's the ratio of their a values. Okay, you guys can kind of take a look at this graph. There's a lot going on here. I'm not sure this is going to be on the test or not. Something about this. We already talked about it once, but I might put it on this test. All right, so what do you do next? Go ahead and complete the homework check and get ready for tomorrow. All right, thanks. That's it.